So hello friends and welcome to another interview preparation session. So it's a continuation from yesterday. So yesterday we had discussed some questions on Python. So let's get to the next topic, that is data science. Today we will be covering the basic questions from data science, the basics only. Okay, so let's get started with the first question. What is data science? Yeah, so what basically is data science? Okay, so data science, we can say it is an interdisciplinary field, means it covers all the many fields which uses scientific methods, processes, algorithm and systems to extract knowledge. And we can use this knowledge to in a broad range of applications, and we can extract knowledge from noisy data, structured data, unstructured data. Every kind of the data we can use for extracting knowledge. So let me repeat that again. So data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from noisy data, structured and unstructured data. And we can apply this knowledge and actionable insights from the data across a broad range of applications. So let's go to the next question. Yeah. So why is data science so popular? Why is it so popular? Okay, I'll answer that. It is so popular because it solves nearly all the problems now. So it is so popular because because of the insights that allows us to the insights that we draw, it allows us to form major innovations and in several products and companies. So this is the cause of major innovations in the past decade. So that is why it is so popular now. Okay, let's go to the next question. So how is data science different from traditional programming? How is data science different from traditional programming? Okay, so in traditional programming, what we used to do is we had an input and we gave some rules and we got an output. But in data science, we have input and we have output and we find out the rules. Means underlying patterns we find out. That is the major difference. Yeah, data science uses algorithms. Also, traditional programming also uses algorithms, not ML. Yeah, data science uses ML algorithms. Yeah. Okay. Let's go to the next one. What is machine learning? Okay, so machine learning is a subfield of data science, first of all. It is a subfield of data science that deals with using existing data to help systems automatically learn new skills. And it also helps the system to perform different tasks without having rules to be explicitly programmed. Means we can discover by learning, we can find out the rules and we can use those rules on other data sets. So we don't have to define the rules, means find out the rules again and again, basically. So what is deep learning next? Now, machine learning was a subset of data science, and here deep learning is a subset of machine learning. So what is deep learning? Okay, so it is a field in machine learning that deals with building ML models using algorithms that try to imitate the processes of how a human brain functions. So in deep learning, we try to imitate the functioning of a human brain, basically. So let's take the next question. What is confusion matrix? Yeah, friends. So any idea on confusion matrix? Okay, so confusion matrix is a table that is used to estimate the performance of a classification model. So we have in this, let me show you, 2 by 2 table. Here we have the predicted values. Here we have the true values. So positive, negative, positive. So when predicted value and true value both are positive, it is called as true positive. When true value is negative and predicted value is positive, it is called as false positive. When true value is positive but predicted value is negative, it is called as false negative. Yeah, yeah, Amar, you are correct. And then we have here when true value is negative and also predicted value is negative, we have true negatives. So let's go to the terms we generally use with confusion matrix. So let's take the next question. What is error rate? Yeah, friends. So what is error rate? So error rate is the number of incorrect predictions, number of incorrect predictions by total number of prediction, by total number of data, total data. So that number of incorrect predictions, here we can say the false positive and false negative are the incorrect predictions. So we get here false positive plus false negative divided by all the data, means true positive plus true negative plus false positive plus false negative. So next, what is accuracy? actually these questions are all for related to confusion matrix only. So when I ask what is accuracy means, what is the formula for accuracy in confusion matrix? Yeah, Maria, correct. Yeah, so Amar has answer. So it is actually number of all correct predictions by total number of predictions, means total data. That is true positive plus true negative divided by this. So let's go to the next one. So what is sensitivity? What is sensitivity? Or we can also call it as recall. It is also called as recall or true positive. Yeah, Pawar, you're right. So it is the total number of correct positive predictions divided by total number of positives. So total number of correct predictions means TP divided by number of total number of positives. So it is TP plus false negative, which is also positive. So next, what is specificity? What is specificity? Or we also call it as true negative rate. Yeah, power, that is correct. So it is true negative divided by total number of negatives. That is true negative plus false positive. No, it is, yeah, true negative. Yeah. So next, what is precision? Or we can also call it as positive prediction value. Yeah, power, correct. So it is number of correct positive predictions by total number of positive predictions. So that is number of correct positive predictions divided by total number of positive predictions. So TP is the number of correct positive predictions, and then we have TP plus false positives. So this is also positive prediction. This is also positive predictions. So we have total number of positive predictions. Next, what is false positive rate? So we had sensitivity, true positive rate, then specificity as true negative rate. So what is false positive rate? Yeah, power, correct. Again. So it is number of incorrect positive predictions, which is false positives. Number of incorrect positive predictions by total number of negative predictions, which is true negative and false positive. And this is also equal to 1 minus specificity. Okay, so we are done with confusion matrix. So let's go to the next questions. So what are the different types of learning methods in ML? Yeah, power, correct. So we have three methods: supervised, unsupervised, and reinforced. Okay, so next, what is supervised machine learning? Okay, so in supervised, yeah, we can say y equal to f of x. Yeah, power, correct. So when we have a labeled data, means we know the input as well as the output data, we can train and then experiment on similar kind of data sets. So it is called as supervised machine learning. So let's take the next. What are the different types of supervised machine learning? Yeah, correct, Pawar. So we basically have two types of supervised machine learning, namely classification and regression. So let's take the next question. What is classification? Yeah, correct, Pawar. Yeah, Amar, you are also correct. So in classification, we have to predict a discrete value. So we deal with maybe yes, no, or pass, fail, like that. Yeah, so Pawar is correct. In classification algorithms, we need to find the class levels of a particular data record. That is absolutely correct. So what are the different algorithms which come under classification. Examples, classification. Yeah, power correct. Decision tree, KNN, SVM, logistic, ensemble can be used for both. Decision tree also can be used for both. Then we have another one, naive Bayes. Yeah. So let's go to the next one. What is regression? Yeah, power. Next, we come to regression. Yeah, Amar, you're correct. It's basically not numerical data because numerical data can also be, discrete. Yeah, power, correct. When we have continuous data as our outcome, we use regression. So we can give an example like prediction of house price given the area, location, number of rooms. So examples, let's take examples of regression. So what are the algorithms used for regression problems? Okay, so what all algorithms come under regression? Yeah, power, correct. So basically decision tree, KNN, SVM, they are used for supervised learning. They come in both. In regression, we have linear regression, multilinear regression mainly, which is used only for regression. Okay, so next, let's go to unsupervised. What is unsupervised? Yeah, power correct. So if we don't have a labeled, means unsupervised is generally used when we don't have a labeled data set. So it is a self-organized learning where it finds the where it finds the underlying patterns and predict the output accordingly. Yeah, Amar, you are correct. There is no labeled data, you can say, no output. Yeah, written. Okay. Yeah. So few of the examples of unsupervised learning are, yeah, right. Clustering, dimension reduction. We can say neural networks, principal component and analysis, then association rules. All these algorithm comes under clustering. So coming to the next question, what is reinforcement learning? The power, correct. So in reinforcement learning, what we have is we have a learning agent, and a start and end state. The learning agent's main aim is to reach the end state, for which it tries to manipulate the environment. And every time it succeeds, it gets a reward. And then failure, no reward is given. So what are the different types of reinforcement learning? Power, actually, you have given the answer to this questions already. Yeah, hi. So what are the different types of reinforcement learning? Basically, there are two types, positive and negative. So what is positive reinforcement learning? Yeah, so anyone know what is positive reinforcement learning? Prava, I'm not getting you, what you're asking. Yeah, so Naveen, it is true for both the cases. Event that occurs because of specific behavior is true for both positive and negative. So I'm telling you. So in positive reinforcement, what we do is we give a reward every time the learner succeeds. Whenever the learner succeeds, we give them rewards. And whenever it fails, we give them nothing. So basically that is positive reinforcement. And similarly, in negative, we have whenever the learner fails, it is punished. So that is a negative reinforcement. And whenever it succeeds, it gets nothing. It just completes its aim, which is reaching the goal. So it is basically that. Now differentiate between supervised, unsupervised, and reinforcement learning. Yeah, Prabha, this is not a doubt session. You can join the doubt session and ask about that. So basically we have discussed this. So let me show you the prepared a table. So supervised machine learning, it learns by using labeled data. Unsupervised, it uses unlabeled data without any guidance. And then we have reinforcement learning. which works on interacting with the environment. Then we have the type of data. Supervised use labeled data, unsupervised uses unlabeled data, and reinforcement machine learning doesn't use any predefined data. Then we have type of problems we face here: regression, classification. In unsupervised, we have association, clustering. In reinforcement, we have exploitation or exploration. So is supervision needed? For supervised, yes, it is needed. For unsupervised, it is not needed. And for reinforcement also, it is not needed. Then algorithms we have already discussed. For reinforcement, we use Q-learning or SARSA. Then we have what is the aim of supervised machine learning? It is used to calculate outcomes. For unsupervised, aim is to discover the underlying patterns. And for reinforcement learning, it is used to learn a series of action, which it uses to reach the goal. Then where we can use these algorithms. So for supervised, we use it in risk evaluation and forecasting sales. For unsupervised, we use for recommendation system and anomaly detection. Then for reinforcement, we have self-driving cars, gaming, and healthcare. Okay, so yeah. So that was the major differences. Then we'll take today's last question. What are some of the popular libraries that we used in Python, that we use in Python? So what are the popular libraries used in Python for data science? Yeah, pandas, numpy, matplotlib, seaborn, sklearn, scipy, stats. Yeah, correct. So we use TensorFlow, which is used mainly for deep learning applications. Then we use NumPy, which is the fundamental library for mathematical and scientific computing. Then we have SciPy, which we can use for complex math, science, and engineering problems. Then we have Matplotlib, which is used for data visualization. Then Pandas, which is used for data manipulation. Then we have Keras, which provides an interface for TensorFlow. Then we have sklearn, which contains all the algorithms for classification, regression, and clustering. So we will be closing here today, and we will be discussing more questions on data science tomorrow. Thank you.